Let's take a look at this problem. We want to graph this system of inequalities. Now first do this on the calculator. We got x plus 2y is greater than or equal to 2, and we got x minus y is less than or equal to 0. Now in order to put these into your TI3, TI4, you have to have y by itself on the left side. So first thing we'll do is we'll work to get that. So on this first one here, we'll take the x, move it over to the right side. So we got 2y is greater than or equal to negative x plus 2. And then we're going to divide everything by 2. So divide 2 by 2. There's an invisible 1 here, so we're going to divide the negative 1 by 2 with an x to the side, plus 2 divided by 2. So we got y is greater than or equal to negative 1/2 x plus 1. We'll do the same thing here. Now, you could take this negative y over and then flip the entire thing around to begin with, but I'll just go ahead and take the x over. People act like it's a horrible imposition to handle a negative in front of your y. It's not that hard. Okay, so the positive x becomes a negative x. And then we're going to divide everything by negative 1 to get to y by itself. So we got negative y divided by negative 1, and negative x divided by negative 1. And remember, when you divide by a negative number, you flip your inequality symbol. So that becomes a greater than or equal to. So we got y is greater than or equal to x. Now, if you got a less than or less than or equal to, then you want a lower left-hand triangle. If you got a greater than or greater than or equal to, you want an upper right-hand triangle. So for these are both greater than or equal to's. So on both of them, we want an upper right-hand triangle. Now if you got less than or greater than, you're going to have a dotted line. If you have a less than or equal to or a greater than or equal to, you'll have a solid line. Both of these are greater than or equal to, so both of these will be solid. Okay, so we got y by itself on the left side. Let's go put these in our calculator. So press my y equals, press my clear wherever in that line, and we'll put in our first one here, which is negative 1/2 x plus 1. So negative 1 divided by 2 x plus 1. Now look where my mouse is. Now try not to do this too fast. Sometimes this hangs up my emulator. Shouldn't hang up your calculator. But you want to keep pressing your left arrow key until you can't press it no more. I mean, you can press it all day long, but once you get over to the first slash here, it won't go any further. So once you're flashing cursors on this first slash, that's where you'll stop. And we said we want an upper right-hand triangle. So press enter one time, and that becomes a thick slash. We press it one more time, and it becomes an upper right-hand triangle. Now while I'm at it, I go ahead and down arrow to y2, and we said this one's going to be an upper right-hand triangle. So I'll press enter twice again, and it becomes an upper right-hand triangle. Now come over here, and instead of 0, I want to put in x. And then I'll press graph. There's y1, and there's y2. Now our answer is where they're both going to be shaded. And you can see they're both shaded up here. And so our answer for this problem if you tilt your head sideways is going to be this right here. Now we said this is going to be a solid line, so what separates the shaded from non-shaded is going to be solid. If we had said it was going to be dotted, then this would have been a dotted line here. Now if one of these is solid and one of them is dotted, then you need to watch it as you're graphing it, because it'll graph y1 first and then y2 second. That'll help you determine which one should be solid and which one should be dotted. Okay, I'm going to show that here by hand in a second, but to clear these out, if you go to y equals, and if I press my clear, On most TI-84s, TI-83s, when you press clear, it not only clears that line, but also clears your triangle over here. On this emulator, it does not clear it out, and on some TI-84s, it doesn't. To get it back to where it was, if you do your left arrow key, my flashing cursor is right here, and you press enter, enter, and as you keep going through these, you'll see the different options. There isn't a whole lot. We want to get back to where it's a regular line. And same way on this one here. We'll just keep pressing enter until we get back to the normal line. Now on some of the newer T84s, the color ones, when you come over here, that does not work. There's actually a menu that pops up. So it'll be a little bit different. You shouldn't have any trouble figuring that out if you've seen it in class. It's still the same idea, but it not only allows you to do color, but also allows you then to choose the type of. It's more of a like a menu, not a menu, screen that comes up, a little mini screen for the different options, and you'll see it. You shouldn't have any trouble figuring it out. It's still based upon the same idea of the upper right-hand triangle or lower left-hand triangle being shaded. Okay, now let's go back to this doing this by hand. Now, doing it by hand, we still want to get y by itself, so that's beneficial. So, I'm down right here, and I got y by itself, so I've got y is greater than or equal to negative 1/2 x plus 1, and y is greater than or equal to x. And, let me see. For the first one here. Now this is, if I were to put an equals here and pretend this is a line, this is y is equal to negative 1/2 x plus 1. Means our 1 at the end, that's our y-intercept, which means we're going to put a point of 1. The number before our x is our slope, negative 1 over 2. Change in y over change in x. That means we'll go down 1, right 2, and that's where we put our second point. And we said they're going to be a solid, since it's greater than or equal to. That line underneath means solid. So it's going to look like this. Tilt your head sideways. I don't know. Oh, I had my tablet turned sideways. Okay. Now we want to pick a test case. And usually your origin is your best one. So if I were to pick 0, 0, you put in your original inequality here. And you could do the original one clear up top or this one here. But if I put 0 here and 0 here, we got 0 is greater than or equal to negative 1/2 times 0, 0 plus 1 is 1. So you get 0 is greater than or equal to 1. If that's true, then you shade decide where that's true. If it's false, I didn't say that right. If it's true, you shade decide where that test case falls. Now let me officially write that out. Okay, so we're picking a test case, test point, and we're picking the origin here, 0, 0. Plugging that in here, we get 0 is greater than or equal to negative 1/2 times 0 plus 1, and this is a question mark. Negative 1/2 times 0, 0 plus 1 is 1, and this is a question mark. If that's true, then we'd shade decide where the test case falls. Well, 0 is not greater than or equal to 1. That's false. So we shade the other side. So instead of shading the side where my test point fell, which was right here, we shade the other side. Okay. Another one. If I were to pretend that's a equals there, that says y is equal to x. Well, that's going to be this line right here. And you should be comfortable with that one because we've seen that as one of our basic graphs in college algebra, y is equal to x. And we want to pick another test case. You probably don't want to choose 0, 0 here because it falls on the line, so that doesn't tell you anything. But let me pick, let me come up here, and I'll pick this point right here, which would be 0, 2. It doesn't matter what you pick as your test point. You probably pick one that looks easy to you. And we want to plug that original inequality. This is our x, this is our y. So we got 2 is greater than or equal to, and this is a question mark, 0. Well, that's true. So we're going to decide where our test case falls. Here's our test case, and it falls on this side of the blue line. So we're going to shade this side of the blue line. Okay. Now, just like before, our answer is where they're both shaded, and you can see they're both shaded up here, which would give us the same graph as we saw right here. So let me just write it down again. If you're a little bit neater at graphing these, then you probably get a better picture of what I'm doing. But you get the idea. Even with special graph paper, I'm still not very neat with these. But that would be your answer.